a small car, where there should be a stop button, which must be a launching button. If the button is pressed, the car must not work. If not, there will be a button to enable forward move. Both motors start in the same direction forward. A button to enable reverse movement. Both motors start in the same directions backward. A button to start turning to the right. Both motors turns in opposite direction, and another buttons to turn to the left. Motors spin the opposite way. For this exercise, it's not necessary to press a stop button to change from one direction to another. Physical and digital buttons must be considered as well as digital LEDs that indicate the movement being performed. On the front panel of the program, give me a minute, 6 buttons were added, one for each movement, one to stop the motors, and one to exit the simulation. Additionally, one LED was added for each motor states for LED simulating each motor moving forward or background. That is for each actions. Two LEDs will turn on depending on the requisite movement of each motors. Finally, 5 more LEDs were added to indicate which physical buttons is being pressed or change its state, just as a visual aid. It's very important to remember that the serial port controller is also present where the Arduino will be connected for the communication. For the diagram block structure were added as a main loop, and inside it a case structure which has an enum variable connected in to its case selector. This variable was changed to its defined form to be able to add each of cases without programming issues. Before starting to display the cases, it's important to highlight that the necessary blocks were placed to start the connection and disconnection of the Arduino with their respective local variables as done in all previously practices. Open and close and this block. Inside in the main while loop structure, all the blocks for reading and writing the states of buttons and LEDs were added. Write this 4 and read this 5. Using 4 write blocks which will send the signal to operate the motors with the help to the H bridge. For this, a local variable was added for each motor movement, MA1, MA2, MB1, and MB2. In its output value tabs, and the numeric constant was also added in defining the pins where each output should be connected to the H bridge, this in the DO channel. In additional, 5 read blocks were placed to identify the state of each physical buttons in their DA channel. tab. A numeric constant was added to identify the pins that will receive the state's reading of each bottoms. Also, a local variables of the LEDs that will indicate which bottom is being present was added connect in the DI value tabs. All the LEDs that will use it were also placed inside the while loop structure, from which their local variables will be extracted to make the program more efficiently. For the initial state, the file of the case structure, all the local variables of each bottoms, both physical and digital, were placed, each shared to its read mode. Um, these are connected or to a digital or gate, with their respective matching pairs, physical and digitally, and the output goes to a selector. In the true value of the structure, an enum variable is placed with a decided case that is, if the physical or digital forward button is pressed, the program will be moved to the case. If not pressed, it will stay in the same case using several selector blocks connected to each other. The output of the last selector connects to the false value to the next one and so on, changing the enums value of each bottoms. At the end, the final value coming from the last selector connected connects to the shift register, connect with the shift register, which will reset its state and thus generate a loop depending on the change of state of any bottoms. As for the visual indication, each one was assigned a local variables and connected to a false constant, which will keep them off in the initial program state. A timer was also added outside the case structure by linked to a constant inside each state to control the program's iterations. For the forward movement case of the car, once either of the two bottoms, physical or digital, is pressed, local variables of each bottom involved in the program, physical and digital, were placed. The same procedure from the previously case was followed. The bottom that activate the same movement are connected to a OR gate, which goes to a selector that has an enum variable for decide the case uh, in its true part, and the false part connects to the output of the previous selector, sharing a nested condition depending of the bottoms. Once the forward movement option is selected, the movement indication forward LEDs and the respective motors LED MA1 and MB2 change their value using a true constant, while either are connected to a false constant to prevent unwanted indication from turning on. For the reverse, right and left case, the same conditions were made using local variables, logical gates, or and selector connected to each other to follow the same procedure, only changing which indicators are turned on. To reverse, LED reverse, MA2 and AB2. For the right LED, right LED. Oh, give me a minute. Oh, right LED, MA1 and AB2. And the left LED, MA2 and AB1. For the digital stop, only, give me a minute. For the digital stop, only the local variable of the digital button was placed, and a selector was used with the respective enum variables to stay in the same case or switch to another. All LEDs are turned off except for the stop state LED. For the physical stop, it's very similar. The two local variables of both stop buttons were placed and connected through an OR logic gate and its selector value. If true, the program returns to the initial case. If fails, it's staying in the same case as before. All visual indications are turned off except for the stop state indication, which remains active. For the operation of Practice 11, the Arduino, the edge bridge, and the buttons corresponding to the control of the two motors are connected. When the digital buttons are pressed, the motors operate, but if another button is pressed, the direction of the motor changes. The physical button works the same way, and the program displays the status of each button with the help of LEDs.